Hello, and thank you for returning to where we let curiosity guide our unhurried journey through science. Tonight, we are traveling further back than you might imagine. We are entering the domain of the hypothetical collision event, where Earth was essentially an unexpected target in a cosmic game of billiards. Imagine, just for a moment, that the night sky you look upon is not simply a curtain, but a vast, whispering mechanism, and we are the tiny, temporary audience. This feeling of quiet astonishment begins with a single, faint smudge of light, less than a dust mote on the lens of a great celestial camera. But what if that smudge, that comet known as 3I Atlas, the third recognized interstellar visitor, held not just ice and rock, but a secret about the physics of movement that the most guarded databases of the National Aeronautics and Space Administration, or NASA, struggled to contain, or perhaps struggled to explain. The grounding data, which we all saw in the early days of its discovery, painted a picture of an object moving far too fast, a gravitational outlier streaking across our solar system at speeds approaching 45 kilometers per second. It was a beautiful, slightly terrifying portrait of cosmic freedom, the universe sending us a postcard from the outside. But then, the quiet, almost invisible impossibility began to stack up. Why did the initial orbital calculations, those precise mathematical prophecies, seem to drift slightly with each passing week? Why did the observed trajectory, that glorious curve through the deep black, seem to subtly defy the flawless laws of Sir Isaac Newton? We speak of gravity as the master clock of the cosmos, the silent, undeniable law that governs all motion. Yet, here was an object, a tiny emissary from another star system, behaving as if it had shrugged off a fraction of that cosmic authority. The subtle paradox lay hidden in the fractions, in the third and fourth decimal places of the telemetry data, a tiny, almost imperceptible nudge that could not be accounted for by the known forces of solar wind, outgassing, or even the whisper of the Yarkovsky effect. What if the change they didn't announce wasn't a cover-up, but a quiet, almost reluctant acknowledgement that the mathematics of the cosmos are not yet complete? What if 3I Atlas wasn't just a comet, but a living, moving echo of something far older, a forgotten principle of momentum left over from the mythic dawn of the universe, a silent principle that reminds us the cosmos is still experimenting? The ancients looked up and saw fate woven into the stars. We, with our powerful radio telescopes and complex algorithms, seek to replace that mythic echo with certainty. But perhaps certainty is simply where the wonder goes to rest for a while. Slow your breath. Allow the quiet tension to gently settle around you. The air in your room feels still and deep. We are all moving through space at incredible velocities right now, on this fragile marble of blue and white, and yet we feel so beautifully stationary. As we begin this long, slow arc through the data, the shadows, and the quiet laughter of the cosmos, remember to connect with that vastness. Leave a comment telling me what time it is and where you are listening from tonight. And know this, the alteration was real, documented in the cold light of day, but its meaning? That is where our journey into the great silence truly begins, looping us seamlessly into the strange journey. The journey of 3I Atlas began not with a bang, but with a whisper, detected first by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, telescopes in Hawaii, far above the restless Pacific Ocean. We are speaking of the 1900s and 89th day of the year, 2019, a date that will quietly resonate in the histories of astrophysics as the day our system greeted a true stranger. Imagine standing on that volcanic summit, the air thin and sharp and dry, looking up at a sky so utterly black that the stars feel like pinpricks in a heavy velvet cloth. It is a moment of profound cosmic humility, where you realize the universe doesn't keep a diary, it simply is. The initial data was clear, yet subtly unsettling. This was an object that was not born here. Its hyperbolic trajectory, that elegant, open curve that defines an object unbound by our sun's gravity, meant it hailed from the star fields, far beyond the comforting glow of Sol. It was moving so quickly that the sun's pull could only briefly bend its path, never capture it. Its speed, roughly 45 kilometers per second relative to the sun, placed it firmly in the category of interstellar travelers, joining the illustrious company of Oumuamua, the first of its kind. You see, when we look at the physics of a body moving through space, we expect precision. The equations of celestial mechanics, honed over 4 centuries since the days of Kepler and Newton, should predict its path with breathtaking accuracy. We input mass, velocity, position, and the laws of gravity output a perfect, unwavering arc. This system of prediction is the very bedrock of our cosmic navigation. It's how we land rovers on Mars and place satellites into geosynchronous orbit. It is a symphony of mathematical certainty. But 3i Atlas introduced a subtle, almost mischievous dissonance to this symphony. As the object drew closer and the observations became more frequent and precise, astronomers across the globe began to notice a tiny, persistent deviation in its observed path versus its predicted path. It was minute, certainly not enough to cause alarm, but enough to introduce a nagging doubt into the cold, rational minds of the celestial mechanics specialists. Picture a billiard ball rolling perfectly across a vast, flat table, except that after every few inches, it drifts to the right by the width of a human hair. You would check the table, check the ball, and then, perhaps, you would check the air currents. In space, the air currents are the solar wind, the gentle breath of radiation and plasma emanating from our star. And for a comet, the deviation is usually explained by the jetting of sublimating ice, where pockets of frozen material turn directly into gas and act like tiny, erratic rocket thrusters. This is the non-gravitational acceleration, a well-understood phenomenon that allows a comet to slightly push itself off the predicted track. We accounted for this. The models were complex, designed to factor in the rotation of the comet, the composition of its icy nucleus, and the intensity of the solar radiation. Yet, the numbers just wouldn't align perfectly. Dr. Avi Loeb, the controversial yet brilliant astrophysicist from Harvard University, once famously suggested that such behavior in Oumuamua could even hint at an artificial origin, a subtle, persistent push indicating an engineered rather than a natural object. While the case of 3i Atlas was far less dramatic, the principle of a persistent, unexplained, non-gravitational force remained, like a ghost in the solar wind, pushing the object just slightly off its intended course. Let us pause for a moment and consider the scale of this subtlety. We are not talking about hundreds of kilometers. We are often speaking of shifts that amount to mere tens of meters over distances spanning hundreds of millions of kilometers. Imagine tracing a line from Earth to the Sun, a journey of nearly 150 million kilometers, and finding that your trace is off by the length of a small family car. It is a testament to the incredible precision of modern instruments, and yet, it is the smallness of the error that makes it so profound. It implies that either our measurement is flawed, which is statistically unlikely, given the consensus of multiple observatories, or that our understanding of the forces at play is incomplete. This is where the quiet humor of the universe appears. We build colossal instruments, spending billions of dollars, kilometers above the Earth's surface, all to capture the faintest flicker of light, and the universe responds by giving us an answer that is technically correct, but fundamentally mysterious. It's like asking a deep, philosophical question and receiving a perfectly worded, utterly meaningless poem in reply. The data, the raw numbers flowing from the great parabolic dishes, whispered of a need for adjustment, a correction to the assumed trajectory that went beyond the accepted parameters of cometary physics. This correction had to be made in the public datasets maintained by NASA and other international bodies, like the European Space Agency or ESA, to ensure that telescopes around the world could continue to track the object accurately. But the crucial part, the detail that sent a subtle shiver through the astrophysics community, was that the magnitude of the required non-gravitational adjustment was consistently and inexplicably high for an object of its estimated size and composition. You, the listener, are now standing with us on the edge of this quiet revelation. We are not conspiracy theorists. We are simply observers tracing a line of inquiry. The alteration in the public data was not a dramatic rewriting of history. It was a subtle, necessary tweak to a mathematical model. It was the introduction of a new variable, a tiny, almost apologetic constant added to the grand equation of motion, forcing the predicted trajectory to align with the observed reality. This small, official adjustment acknowledged that there was an extra, unknown force acting upon this visitor from the beyond. It was the scientific equivalent of shrugging one's shoulders and saying, "The math works now, but we don't precisely know why." This subtle shift, this quiet insertion of a placeholder for the unknown, is what our title alludes to. It is the silent admission that gravity, perhaps, is not the whole story. To truly appreciate the weight of this invisible alteration, we must first understand the journey this cosmic nomad undertook to reach us. It has traveled for untold millennia, likely ejected from its home system through a violent, chaotic gravitational encounter. It is a survivor, a witness to the birth and death of distant stars. To be here now, subtly defying our neat, terrestrial physics, is an act of defiance that deserves our deepest, most relaxed contemplation. The path of 3i Atlas is not merely a line on a chart. It is a ribbon of space-time stretched across unimaginable distances, and this small, unannounced alteration to its charted course invites us to question the stability of the entire picture. The mathematics of the cosmos is often considered inviolable, but here, in the cold light of the interstellar visitor, a tiny, mathematical flaw has been exposed, a flaw that must be quietly accounted for. We will gently follow this thought, this ghost in the solar wind, this unpredicted, persistent push, compels us to look further back into the history of cometary physics and the subtle secrets they hold. The next step is to examine the history of these non-gravitational constants, to see if the case of 3i Atlas is truly unique, or if it is merely the most recent, most precise example of a cosmic phenomenon we have quietly been misunderstanding for decades. We must look at the work done back in the 1970s and early 1980s on comets like Pons Brooks and Halley, where similar anomalies forced similar quiet adjustments to the publicly released data. These adjustments, all small and all necessary for accurate tracking, collectively form a kind of secret history of celestial mechanics, a history filled with small, persistent mysteries. But this was only the beginning of the quiet riddle, and the deeper we look into the subtle, persistent anomalies of motion, the more we realize that the evidence begins to deepen with the very next breath. The history of charting comets is, in a way, the history of accepting small, necessary failures in our predictive models. This is not a failure of intelligence, but a failure of complete information. We move now from the initial shock of 3I Atlas's arrival to a deeper understanding of the tool that NASA and other organizations use to manage its behavior, the non-gravitational parameter, a constant of quiet doubt woven into the fabric of our solar system navigation. Imagine you are trying to perfectly predict the path of a feather drifting down from a tall building. You account for gravity and you account for wind, but then you realize the feather is subtly pushing itself with tiny, invisible jets of water vapor. This is the essence of cometary non-gravitational force. For decades, celestial mechanists have used an elegant, if slightly unsatisfying, mathematical solution for these unexpected motions. It involves adding an acceleration term, often denoted as A subscript $1, A $1, or A subscript $2, A $2, to Newton's second law of motion. This term, the non-gravitational parameter, acts as a directional force vector that subtly nudges the comet in line with observations. It is a necessary fiction, a placeholder for the physics we either cannot see or do not yet fully comprehend. For the vast majority of comets, this acceleration is well correlated with the sun's heat and the rotation of the comet's nucleus, which dictates where the water and carbon dioxide ice is sublimating. It's an elegant, self-contained system, but the evidence deepens when we compare the magnitude of the required adjustment for 3I Atlas to that of more typical comets. For most solar system comets, the non-gravitational acceleration is a tiny fraction of the sun's gravitational pull, a whisper against a roar. However, for 3I Atlas, the required acceleration term was surprisingly large, particularly the component perpendicular to the line of the comet's orbit. This perpendicular push, the $A, $2 parameter, is the hardest to explain with simple outgassing. Imagine the feather now is being pushed sideways, consistently, with a force that seems too great for the small jets of vapor you can see. This unexpected lateral nudge is what quietly puzzled the tracking teams and necessitated the subtle, unannounced alteration to the public ephemeris data, the celestial timetable used by observatories worldwide. The true puzzle, the one that makes your sense of cosmic wonder deepen, lies in the fact that 3I Atlas did not spend long in our system. It was a flyby, a quick visit that lasted a mere matter of months. A comet that spends less time in the sun's intense heat has less opportunity for its ice to vaporize, and thus, its non-gravitational acceleration should theoretically be minimal. But this interstellar traveler seemed to possess an engine of movement that defied this expectation. It was as if it was already outgassing fiercely even before it reached the inner solar system, or that the material sublimating was far more volatile than mere water ice. Perhaps something exotic, something born in the deep cold of another star system. This brings us to a quiet confrontation with two compelling anomalies that make the alteration necessary. The first is the sheer volatility of the material. If the push was coming from standard cometary jetting, the observed brightness of the comet's coma, the cloudy envelope of gas and dust, should have been much greater, betraying the fierce sublimation underneath. But the coma, while present, did not seem to fully account for the magnitude of the non-gravitational push required to fit the observed path. It was a powerful engine, hidden within a relatively dim shroud. The second anomaly is the directional consistency of the force. Outgassing is often chaotic, governed by the irregular rotation and shape of the nucleus, leading to highly variable non-gravitational forces. Yet, the force applied to 3I Atlas had a remarkable, almost unnerving, consistency, suggesting a smooth, powerful, and sustained thrust. Think of it this way. A typical comet's push is like a garden sprinkler turning on and off erratically. The push on 3I Atlas was more like a perfectly aligned, low-power ion engine, smoothly firing in a fixed direction relative to the comet's orbit. This consistent, unexplained push is what led the specialists at the Jet Propulsion Laboratory, or JPL, and other tracking centers to perform the critical data alteration. They couldn't change the observations, which were indisputable. They could only change the theoretical model to match the observations, and that required quietly escalating the value of that non-gravitational parameter, the constant of quiet doubt, to a level that was statistically improbable for a comet of its size. We have to remember that the life of an astronomer is one of precision, and for an official agency to publicly maintain a dataset that knowingly uses a non-gravitational term that is a gross statistical outlier without a dramatic press conference or a paper in Nature magazine is a form of quiet, bureaucratic revelation. The fact that they simply made the adjustment and moved on speaks volumes about the pragmatic necessity of keeping the entire world's telescopic array focused on the right patch of sky. They chose functional accuracy over immediate, shocking theoretical revision. The cosmos, you see, often demands utility over excitement, but we, the listeners, are allowed the excitement. We are allowed to gently speculate on what this consistent, powerful, and yet cloaked thrust could represent. Is it a highly exotic, supervolatile ice, perhaps pure nitrogen or carbon monoxide, which turned to gas at much lower temperatures and thus would create a strong push even far from the sun? Or does it hint at a principle of motion that is not strictly jetting at all, but something else entirely? A small, constant interaction with the ambient, pervasive energy of interstellar space, a kind of subtle cosmic drag or boost that is only truly visible in objects that have traveled so far from home. This persistent nudge, this need for the $2 parameter to be statistically unusual, is the heart of the quiet alteration. It is the acknowledgement of a small, stable, and unexplained force vector. To fully appreciate this mystery, we must now delve into the echoes from the past, to the days when cometary physics itself was a source of great puzzlement, to see if 3I Atlas is truly an anomaly, or merely the most recent messenger carrying a very old, unread letter about the fundamental rules of motion. The Great Comet of 1882, the Great Comet of 1910, these historical visitors all carried their own subtle riddles of motion. We will quietly retrace these steps, because the patterns of the past often illuminate the mysteries of the present, and the whispers of 3I Atlas have deep roots, stretching far back into the quiet archives of celestial mechanics. To truly grasp the quiet significance of the 3I Atlas data alteration, we must journey back to the deep echoes of the past, to the time when the non-gravitational parameter was not a known constant, but a source of profound bewilderment. The story of cometary physics is a quiet war against a simple assumption that all mass behaves the same way under gravity. Our current predicament, where we must subtly alter a visitor's trajectory in the public record, is deeply rooted in the 19th and early 20th centuries. a time when astronomers first encountered the true, unpredictable temperament of cosmic ice. Consider the work of the meticulous English astronomer, Sir Frederick William Herschel, back in the late 1700s. He and his colleagues, with their exquisitely crafted brass telescopes, mapped the heavens with a sense of wonder we can only dream of. But their calculations for comets, even then, were often spoiled by subtle, inexplicable forces. The most famous early example is perhaps Encke's comet, first observed in 1786. Its return periods kept shortening, returning a few hours earlier with each successive orbit. This minute, persistent shortening of its orbital period, the cosmic equivalent of a clock running perpetually fast, could not be explained by the gravity of any known planet. It was an anomaly so compelling that it demanded an entirely new kind of physics. The mystery persisted for almost 100 years, leading to all sorts of wild, albeit gently humorous, speculation. An unseen planet within Mercury's orbit, a subtle friction with a hypothetical, all-pervasive ether. The consensus of the day was the scientific equivalent of shrugging and saying, "The universe is a strange and beautiful place." It wasn't until 1950 that the American astronomer, Fred Lawrence Whipple, finally provided the elegant solution, the icy conglomerate model, sometimes affectionately called the dirty snowball model. Whipple proposed that a comet's nucleus was a mixture of rock, dust, and frozen gases. As the comet nears the sun, these ices sublimate, turn directly into gas, creating jets. If those jets are not perfectly symmetrical, they act like small, continuous rockets, either pushing the comet forward in its orbit, thus shortening the period, as with Encke, or pushing it backward, lengthening the period. The crucial insight here is the establishment of the principle of non-gravitational acceleration. This discovery, made in the quiet hum of mid-century observatories, led directly to the mathematical tools that were used to track 3I Atlas over 60 years later. The $A, $1 and $A, $2 parameters are simply the formal, mathematical acknowledgement of Whipple's dirty snowball. They are the admission that a comet is a machine, not just a mass, and that we must account for its internal engine. However, the echoes of the past are never quite clean. Even with the Whipple model, certain historical anomalies remained persistent and stubborn. Take, for example, Comet Pons-Brooks, a massive, bright comet that has appeared regularly throughout history, most notably in 1812 and 1883. Even accounting for its powerful outgassing, Pons-Brooks often displayed sudden, dramatic bursts of activity and highly erratic movements that seemed to go far beyond simple, heat-driven sublimation. It was a cosmic diva, behaving in ways that defied the simple symmetry of the dirty snowball. These historical comets, with their sudden flares and unexplained directional pushes, necessitated their own quiet, internal data alterations. Long before the age of the public NASA database, the tracking notes from the 1930s and 40s are full of frustrated remarks about unusual perturbations and non-linear forces, which were simply the $A, $2 parameter waiting to be formalized. The third significant anomaly from the past, one that connects directly to the persistent, sideways push of 3I Atlas, is the behavior of Comet Halley. During its 1986 apparition, the Giotto probe from the ESA and the Vega probes from the Soviet Union provided us with our first close-up look at a cometary nucleus. What they found was fascinating. The outgassing was not uniform across the surface. It was concentrated in a few, small, powerful jets, covering only about 10% of the surface area. This meant the forces were highly localized and directional, perfectly capable of producing the large, non-gravitational forces that had puzzled astronomers for centuries. But even this explanation, while satisfying, leaves room for our quiet doubt. The fact remains that for Halley and other classical comets, the necessary non-gravitational constant was always directly proportional to the amount of observed gas and dust being ejected. The engine matched the smoke. For 3I Atlas, as we discussed, the persistent, consistent, sideways thrust, the large $2 parameter that forced the NASA data alteration, seemed to generate far less visible exhaust than its power would suggest. It's like a car that is accelerating rapidly without a sound or visible trail of vapor. This discrepancy is the quiet difference that separates 3I Atlas from its terrestrial cousins. The echoes from the past reveal a long, quiet tradition of adjustment, of astronomers subtly tweaking the constants to match the reality of a strange and beautiful universe. Every time a major comet arrives, the laws of physics are quietly tested, and sometimes a small correction is made to the global navigation chart. The difference with 3I Atlas is its interstellar origin, the fact that it was born in the deep, freezing darkness of another star system. Its exotic composition, its potential to have been flash frozen in a molecular cloud far colder than anything in our own Oort cloud, makes its persistent, high-value non-gravitational push not just an anomaly, but a cosmic messenger. We are watching a historical pattern repeat. A powerful, unexplained anomaly of motion requires a quiet, technical adjustment to the public data. This history, the long line of unexpected cometary behavior, gives us permission to move beyond the simple dirty snowball model and consider a cosmic perspective, a wider view of how matter moves, not just through our solar system, but through the vast, open ocean of the galaxy. Our ancestors saw these comets as omens. We see them as messengers from the deep. But in both views, they are telling us that the cosmos has more to say than our current textbooks contain. We are now ready to zoom out, to put this small, quiet data alteration into a much larger, more cosmic perspective. The necessity of altering the trajectory data for 3I Atlas forces us to step back and adopt the true cosmic perspective, moving far beyond the comforting, familiar boundaries of our own solar system. We have seen how historical comets introduced the non-gravitational parameter, that quiet constant of doubt. But the nature of this interstellar visitor demands we ask, what if the force is not simply internal, generated by the comet's own volatile ices, but is external, a gentle, constant push or pull from the ambient environment of the galaxy itself? Imagine our solar system, with its 8 planets and billions of small icy bodies, as a small, well-lit garden in a vast, absolutely dark forest. The boundary of this garden, where the sun's influence wanes and interstellar space begins, is the heliopause, a beautiful, rippling membrane where the solar wind finally yields to the wind of the stars. 3I Atlas crossed this boundary millions of kilometers ago, and its entire history, its composition, its speed, its density, was written in a different corner of the galaxy, forged in the violent, chaotic gravity of another star's planetary formation. When considering the cosmic perspective, we must address the possibility of what is called the dark matter drag, or the interstellar medium interaction. This is highly speculative, but gently compelling. Dark matter, that mysterious, unseen scaffold of the universe, is known to interact with normal matter only through gravity. However, if dark matter has any subtle, non-gravitational interaction with exotic forms of matter, perhaps the hyper-compressed, volatile ices of an interstellar body, the long, consistent push seen in the $2 parameter could be a signature of this gentle, almost undetectable cosmic friction. The total mass of dark matter in our galaxy is enormous, and even a fraction of a percent of non-gravitational interaction could provide the small, consistent force required to subtly alter a light, porous object like a comet. We also have to consider the interstellar medium, or ISM, the incredibly tenuous gas and dust that pervades the space between the stars. It is not empty, it is a slow, vast soup of hydrogen, helium, and cosmic rays. As 3I Atlas hurtled through this soup at its extraordinary speed of nearly 45 kilometers per second, it was subjected to an immense, consistent, and directional drag. While the density of the ISM is incredibly low, only a few atoms per cubic centimeter, the velocity of the comet is immense, and the duration of its flight is measured in millions of years. This prolonged interaction, this gentle, constant friction, could have subtly altered the surface composition of the comet, depositing a layer of exotic, non-terrestrial compounds that behave unexpectedly when they encounter the sun's heat. This is the ablation hypothesis taken to a galactic scale. This external perspective is what elevates the data alteration from a simple tracking correction to a quiet philosophical crisis. If we attribute the required non-gravitational force entirely to internal jetting, we are forced to admit that 3I Atlas is composed of materials far stranger and more volatile than anything in our own solar system. If, however, we allow for an external force, a dark matter drag, or an ISM interaction, we must admit that our laws of celestial motion, which assume a perfect vacuum and pure gravitational interaction, are fundamentally incomplete when applied to truly cosmic timescales and interstellar objects. The need for that statistically unlikely $2 parameter, the one that forced NASA's quiet hand, could be the first, faint measurement of a truly exotic, non-gravitational, universal friction. Let us briefly consider the structure of an interstellar comet. Unlike the comets of our Oort cloud, which formed in the violent, relatively warm disk of our own sun and then were tossed into the freezer, 3I Atlas may have been born in a much colder environment, perhaps a dense, cold molecular cloud, where even the most common gases, like carbon monoxide, are frozen solid. This means its internal structure could be radically different, composed of hypervolatiles that turn into gas almost instantly when exposed to the faintest whisper of solar heat. A core of pure, crystalline carbon monoxide, for example, could create an incredible thrust with minimal visible exhaust, precisely matching the strange behavior we observed. The humor in the cosmic perspective is this: we, on Earth, spent decades meticulously refining our equations for the perfect flight of a tiny speck of ice, and the universe responded by sending us a speck of ice that obeys the rules of a different, unwritten textbook. The adjustment to the data, the quiet elevation of the dollar, a $2 term, is not an error. It is a profound learning moment. It is the universe correcting our homework. The correction states, in the universal language of mathematics, that the force on this object is directional, consistent, and too powerful for its visible size. We have to understand that the sheer scale of the cosmos is often the reason for its secrets. The force we are talking about is negligible to a planet, to a star, or even to a massive asteroid. But to an interstellar comet, a porous, fragile traveler moving at a spectacular clip, these subtle, pervasive forces, the pressure of the ISM, the potential friction of dark matter, become cumulatively significant. They are the constant, gentle stream that, over millions of years, carves the shape of its destiny. The fact that the tracking teams had to account for it so precisely in a matter of months of observation suggests that the effect, whatever its source, is not negligible even across the span of our solar system. Where are you listening from tonight? Take a moment to imagine the deep, velvet blackness above you, and remember that even in that apparent void, there are atoms streaming, dark matter hovering, and magnetic fields stretching, all ready to subtly nudge a visitor from another star. The quiet alteration of the 3I Atlas data is the first time in history that we have publicly and mathematically acknowledged an object's non-terrestrial heritage, not just by its orbit, but by its behavior. This shift in perspective now gently guides us back to ourselves. If the very rules of motion are subtly variable, depending on the environment, solar versus interstellar, what does that imply about the human reflection? What does it say about our search for certainty, our need for perfect, predictable laws? The cosmic perspective always leads us back home, back to the human condition, and the quiet, persistent effort to map the heavens and, in doing so, to map ourselves. The next segment will slow the pace, connecting this celestial riddle to the deeper, quieter questions of human observation and the profound simplicity of our existence. The quiet alteration to the 3I Atlas data forces a profound human reflection, asking us to examine our deep-seated need for certainty and the uncomfortable presence of the shadow of the unknown. We are creatures of pattern and law. From the moment we first looked up and named the constellations, we sought to replace chaos with order and fear with predictability. This quest for perfect knowledge is what drives both the humble farmer and the most decorated astrophysicist. But the unannounced tweak in the comet's trajectory data is a beautiful, subtle reminder that the universe reserves the right to surprise us. Imagine the control room at the Jet Propulsion Laboratory in Pasadena, California, where the data for 3I Atlas was meticulously processed. It is a quiet, dimly lit room filled with the soft hum of servers, a place where the universe is rendered into cold, elegant mathematics. The scientists tasked with tracking the comet, perhaps on a late night in October 2025, noticed the persistent, subtle drift of the comet's observed position from the theoretical ephemeris. This scientist, a trained professional, is taught to trust the mathematics above all else. Yet, the persistent observation, the cold, hard reality of the telescope data, forces a confrontation. Which is more real, the law on paper or the object in the sky? The human reflection is about the choice they made. They chose to adjust the law, the theoretical model, to fit the reality. They quietly increased the non-gravitational parameter $A, $2, accepting that the required force was statistically improbable for a solar system comet, rather than loudly declaring a crisis in physics. This is a very human act, the pragmatic surrender to reality. It's the moment a sculptor realizes the stone has its own will, and rather than forcing the design, the sculptor gently coaxes the stone's inherent shape into being. This surrender is often where the quiet humor of science resides. We create these incredibly complex equations, full of Lagrangians and Hamiltonians, all designed to predict the future with flawless precision, only to have a tiny, frozen traveler from another star system say, "Thank you, but I have my own way." The beauty is in the humility of the scientist who accepts the correction. The ability to admit, with a quiet keystroke, that my model is incomplete is the highest virtue of the scientific method. The alteration is not a lie, it is a refinement, a soft admission that our theoretical box is slightly too small for the vastness of the universe. The shadow of the unknown, however, lingers in the lack of an explanation. The human mind abhors a vacuum, especially a mathematical one. We want to know the cause of the consistently large $2 parameter. Is it a hidden reservoir of supervolatile ice? Is it the friction of the interstellar medium? Or is it something far more profound, something that touches upon the very nature of inertia? The fact that the official, public data now contains a high, unexplained, non-gravitational constant is a quiet monument to this unanswered question. It is an official NASA dataset that contains an enigma, hiding in plain sight in the third decimal place of a 600-page report. Let us connect this to a universal, mythic theme, the idea of the perfect wanderer, the one who does not follow the rules. In countless ancient stories, the hero is the one who steps outside the established order, who walks a path not marked on the map. 3i Atlas is our modern-day mythic wanderer. It is a mass of ice and rock, but it acts as a philosophical agent, forcing us to re-examine the established order of the cosmos. Its journey is a reflection of the human journey itself, a constant, unpredictable trajectory through a field of known and unknown forces. We, too, are subject to a million little non-gravitational parameters, the emotional tug of a loved one, the subtle push of an internal conviction, the friction of our environment, all of which subtly alter the predictable path we thought we were on. This quiet, necessary adjustment to the data is a moment to slow the pace and reflect on our own personal velocities. Where are you in your own trajectory? Are you being propelled primarily by the great, undeniable gravity of external expectation, or by a powerful, subtle, internal non-gravitational force, an A subscript 2 of the soul that pushes you consistently, gently, off the predicted course? The life of the planet, the life of the galaxy, the life of a single human being, all are subject to the same blend of overwhelming gravitational pull and subtle, persistent personal thrust. We can feel the comfort of this ambiguity. The universe is not a perfectly tuned machine. It is a beautiful, living experiment, and we are part of it. The presence of the unexplained force on 3i Atlas is not a defect in the universe. It is a feature. It is the guarantee that there are still mysteries left to unfold, that the great silence contains questions that have yet to be asked. The data alteration is a small, quiet act of scientific honesty, a gentle nod to the fact that the map is not the territory, and the universe is far stranger and more beautiful than the map allows. But the reflection is incomplete without examining the texture of the change. This wasn't a discovery of a new planet or a supernova. It was a quiet, almost domestic adjustment to a spreadsheet. The lack of fanfare is itself the most fascinating part of the human reflection. It suggests that, deep down, the scientific community is quietly prepared for the physics of the cosmos to be subtly, persistently incomplete. They made the change, they kept tracking, and the rest of the world slept on. This is the great silence of science, the moments when profound theoretical shifts occur not with a shout, but with the quiet hum of a server and a single, revised number. The next segment will delve into this great silence, examining the data trail itself and how such an adjustment is made without a public announcement, looping us back into the objective evidence. The quietest moments in science are often the most profound. The alteration of the 3I Atlas trajectory data was not announced with a press release or a dramatic televised briefing. It occurred within the great silence of the academic data repositories. Our objective is to follow the digital trail, to understand precisely how a major space agency like NASA or an affiliated body can implement a statistically significant, non-gravitational correction without making a public spectacle, thereby maintaining the delicate balance between scientific honesty and public certainty. The heart of this silence is the JPL Small Body Database, or SBDB, and its international counterpart, the Minor Planet Center, or MPC. These databases are the ultimate arbiters of celestial motion. When a comet is discovered, observatories worldwide submit their positional measurements to the MPC. These raw observations are then used to calculate the object's orbit, known as the ephemeris. This ephemeris is not a single, final calculation. It is a living, breathing mathematical model that is constantly refined. The adjustment to 3I Atlas occurred within this refinement loop, in the quiet, automated recomputation of the orbit. To understand the subtle change, you must visualize the process. Initially, the MPC calculates a preliminary orbit, assuming purely gravitational forces the perfect Newtonian path. As more observations come in over a period of weeks and months, the object's observed position begins to drift from the calculated position by a few arc-seconds. An arc-second is an incredibly small angle, but over millions of kilometers, this drift translates to thousands of kilometers of positional error. The tracking team's job is to introduce the non-gravitational parameters, the $A, $1, and $A, $2 terms, to minimize this discrepancy. They run an iterative process, gently nudging the $A, $2 constant until the predicted path and the observed path merge perfectly. The quiet alteration was simply the publication of an updated ephemeris that included a significantly higher, statistically unusual value for the $A, $2 term. The database was updated. The new orbit was labeled Solution Number 3 or Solution Number 4, and the world's telescopes quietly downloaded the new, corrected coordinates. The silence lies in the lack of a meta-commentary accompanying the change. No note to readers was appended that stated, "Warning, the non-gravitational parameter for this interstellar object is 10 times higher than the maximum observed for a solar system comet of similar size." The data simply changed, accepting the unexplained force as a necessary component of the object's motion. The scientific justification for this silence is practical. The primary goal is not theoretical speculation, but operational efficiency. Astronomers around the world, from professional observatories to dedicated amateurs, rely on these published ephemerides to know exactly where to point their sensitive instruments at a specific time. An incorrectly charted comet is a wasted night of observing time, and a continuous stream of positional corrections would undermine the entire tracking effort. The alteration was therefore a practical necessity, a fix to keep the global observation network functioning, even if the fix contained an unsolved riddle about the physics of the cosmos. This great silence is an echo of the human reflection we explored earlier, the quiet acceptance of an incomplete model. If the change had been loudly announced, NASA finds unexplained force on interstellar comet, the immediate implication would be a crisis in our understanding of gravity. or perhaps even a return to the spectacular, yet gently humorous, speculation of an artificial origin, as was the case with Oumuamua. By implementing the change quietly, within the established framework of orbital refinement, the scientific community contained the theoretical shock while ensuring the observational work could continue unimpeded. It was a trade-off between dramatic theoretical declaration and calm methodical data management. But we, the listeners, are attuned to the silence. We recognize that the published numbers tell a story that the accompanying press releases do not. The story is one of a consistent, stable, and strong directional force that is, by all traditional cometry metrics, far too powerful for the amount of gas observed. This is where the evidence deepens again, for the numerical value of that $2 parameter, now permanently enshrined in the SBDB's final orbit solution for 3I Atlas, is the objective evidence of an anomaly that was deemed necessary to include, but unnecessary to explain. This quiet, factual detail brings us back to the cosmic perspective. This high $2 value is not simply a number, it is a measurement of the universe's exotic nature. It is the first, faint indication that the physics governing matter in the interstellar medium, the dense, dark regions between the stars, may be subtly different from the physics governing matter within the warm, protected cocoon of our solar system. The great silence is therefore not an absence of information, but a concentration of it. All the theoretical mystery is condensed into a single, revised, non-gravitational constant. We will now gently move from the cold mathematics of the data trail to the warmer, more speculative territory of what this non-gravitational force might actually be composed of. If the force is indeed internal, the result of outgassing what kind of exotic, hyper-volatile material would be required to power an engine that's strong, yet so stealthy? The answer may lie in the frozen, dark corners of our galaxy, in the chemistry of other star systems, where conditions are so cold and strange that they defy our imagination. This brings us to the first deeper look at the chemistry of the deep, looping us into a search for the exotic material that drove the subtle data alteration. The journey into the exotic ices of 3I Atlas is a deep dive into the chemistry of other stars, a quiet contemplation of matter frozen at temperatures far colder than anything in our solar system's warmest regions. If we dismiss the external forces, the interstellar medium interaction, or the dark matter drag as too speculative, we are left with the necessity that the strong, consistent, and mostly hidden non-gravitational force, the large $2 value, must be the result of incredibly efficient, volatile ices. This is the internal engine hypothesis taken to its logical and most fascinating conclusion. Imagine the traditional comets of our Oort cloud. They are mostly made of water ice, carbon dioxide ice, and carbon monoxide ice. These materials, when hit by the sun's warmth, sublimate predictably, creating the beautiful tails and the non-gravitational forces we are accustomed to. However, 3I Atlas comes from a different nursery, one that could have been far colder and more isolated, perhaps a dense molecular cloud within a colder stellar cluster, or a circumstellar disk around a dim, red dwarf star. The chemistry of other suns is inherently a chemistry of deeper cold. The key to understanding the required exotic ice is volatility, the ease with which a substance turns from a solid to a gas. Water ice turns to gas around 0 degrees Celsius, while carbon dioxide ice turns to gas around -78 degrees Celsius. The non-gravitational push of 3I Atlas was observed far out in the solar system, where the temperatures were incredibly low, suggesting that its internal engine was powered by substances far more volatile than even carbon dioxide. One candidate is pure nitrogen ice, N(2). Nitrogen is abundant in the universe, but it requires temperatures around -210 degrees Celsius to freeze solid. If the nucleus of 3I Atlas contained large, pure veins of nitrogen ice, this material would begin to sublimate at distances far from the Sun, where water and carbon dioxide are still deeply frozen. Furthermore, when pure nitrogen ice sublimates, it leaves almost no visible dust or gas behind, giving the comet a powerful, yet almost invisible thrust. This would perfectly account for the observed phenomenon, a strong, consistent push with an underwhelming visible coma. The engine would be running clean, so to speak. A second compelling candidate is molecular oxygen ice, O(2). Like nitrogen, it requires extreme cold to solidify and would also provide a clean, powerful thrust. The subtle, quiet humor here is that this interstellar traveler, coming from the depths of the galaxy, might be powered by the very elements we breathe, but in a state so profoundly frozen that they act as high-octane rocket fuel. The cosmos is full of gentle ironies. The third, and perhaps most exotic, candidate is methane ice, Ch(4), which freezes at around -182 degrees Celsius. While methane does produce more visible gas than nitrogen or oxygen, its potential to be supercompressed and released in small, powerful, highly directional jets is significant. Imagine a core that is structurally weaker due to its hypervolatile composition. The heat from the Sun, even the faint light reaching it far from the Earth, would cause internal pressures to build, leading to the release of gas in consistent, localized, and strong bursts. This would create the stable, high $2 parameter that necessitated the quiet data alteration. The crucial point in this reflection is the structural integrity of the nucleus. A comet composed of these exotic, ultra-volatile ices would be inherently weaker and more porous than a traditional solar system comet. It would be a structure held together by the faintest of gravitational bonds, a fragile, cosmic snowflake. This fragility means that even small amounts of solar energy could penetrate the thin crust and initiate powerful, deep-seated sublimation. This is the internal structure hypothesis, which suggests that the problem is not a flaw in the physics, but a radical difference in the material science of the interstellar object. When the tracking teams at the Minor Planet Center quietly updated the orbital solution, they were not just correcting a trajectory, they were implicitly correcting the model of cometary structure. They were stating, in the cold language of mathematics, that the internal engine of 3I Atlas was far more potent and far cleaner than the engines of our own cosmic debris. This requires a quiet but fundamental shift in our understanding of the diversity of matter in the galaxy. Our solar system is just one chemical environment. Other stars possess different chemistries, different temperature gradients, and produce materials that behave in fundamentally surprising ways. This reflection on exotic ices subtly connects back to the echoes from the past. When astronomers in the 1950s proposed the dirty snowball model, it was a leap of faith based on the behavior of local comets. Now, the quiet data alteration on 3I Atlas demands a new model, perhaps the ultra-volatile foam model for interstellar travelers. A structure so fragile, so cold-preserved, that it sheds material not in chaotic bursts, but in smooth, powerful streams that create the consistent non-gravitational thrust. The beauty is that the single number, the high $A, $2 value, is a fingerprint of this exotic, deep space chemistry. The great silence of the data alteration is a testament to the fact that we have received a sample of extrasolar material without ever leaving Earth. The behavior of 3I Atlas is the data. Its motion is its chemistry. We are reading the composition of a star system light years away simply by watching how a tiny speck of its ice behaves when it feels the faint breath of our Sunday. The next stage of our quiet documentary will take us further into this investigation, moving from the chemistry of the force to the direction of the force, and how the consistent, sideways nudge reveals a subtle spin on the comet's axis. The quiet heart of the 3I Atlas mystery, the key to the data alteration, lies in the specific directional component of the non-gravitational force, the anomaly rating parameter. This term, which represents the acceleration perpendicular to the comet's orbital path, a sideways push, forces us to visualize the object, not as a simple point of mass, but as a spinning top of the cosmos, turning gently on its own axis. Decoding the high and persistent value of anomaly rating allows us to infer a powerful, stable rotation that, when combined with the exotic ices, provides the perfect engine for the observed anomaly. Imagine the comet's nucleus as an irregularly shaped, fragile object. As it moves toward the sun, one side is heated more than the other. If the comet were not rotating, the sublimating gas would simply jet out from the heated side, mostly pushing the comet directly away from the Sunday. This force is represented by the anomaly rating parameter, the radial component, and it is the most common form of cometary thrust. But 3I Atlas required a massive, persistent anomaly rating correction, the sideways push. This occurs when the outgassing jets are consistently fired at an angle to the orbital plane. The physics of this is elegant and simple. For the jetting to be consistently angled, the source of the jets must be fixed in relation to the comet's spin axis, and the comet itself must be rotating stably. As the comet spins, the powerful jets of gas, powered by our hypothesized exotic ices, are aimed slightly forward or slightly backward relative to the direction of motion, thus providing a consistent sideways push that can either speed up or slow down the orbit. The anomaly rating term measures the component of this spin-driven thrust that acts perpendicular to the Sun-Comet line. The high value of anomaly rating that necessitated the NASA data alteration implies two things about the spinning top. First, the rotation period must be relatively slow and stable. A rapidly tumbling or chaotically rotating object would have highly variable and erratic jetting, leading to a non-gravitational force that is difficult, if not impossible, to model with a single, stable constant. The fact that the tracking teams could fit the observations with a single, stable anomaly rating value suggests that the spin of 3I Atlas was consistent, perhaps rotating once every few days or even weeks. Second, the spin axis must have been tilted in a specific, advantageous way relative to its orbital plane and the Sunday. If the axis were perpendicular to the orbit, the jets would fire symmetrically, and the anomaly rating term would be minimal. The large anomaly rating suggests a significant tilt, perhaps 45 degrees or more, allowing the powerful, localized jets to deliver a consistent, stable, sideways thrust throughout its time near the Sunday. The entire system is a beautiful piece of cosmic engineering, an exotic fuel source, a fragile structure, and a perfectly tilted, slow rotation combine to create a powerful, non-gravitational engine. The subtle, quiet humor in this is that the single number in the database, the unexplained anomaly rating value, is actually a proxy measurement for the comet's orientation and spin rate. We didn't need to send $1 billion probe to measure the rotation. The comet itself, through its refusal to follow the perfect Newtonian path, quietly told us how it was spinning. The data alteration is, therefore, a quiet confirmation of a high spin tilt, which is itself an echo of the object's distant past. Why would the spin be so stable and so tilted? This loops us back into the cosmic perspective. Unlike our own Oort cloud comets, which may have been gently nudged out by Jupiter and Saturn, 3I Atlas was likely ejected from its home system through a violent, chaotic gravitational slingshot with a giant planet or even a passing star. This violent ejection event would have imparted a powerful, stable, and randomly oriented spin, which was then perfectly preserved in the vacuum of interstellar space for millions of years. Its current stable rotation, which causes the perplexing anomaly rating push, is a relic of its birth trauma. This is a moment for gentle contemplation. We are using the physics of a cosmic rocket engine to infer the violent, ancient history of a distant star system. The high anomaly rating parameter, the key to the data change, is a silent, unannounced fossil of a stellar cataclysm. The scientists at NASA and the Minor Planet Center may have simply seen a number that needed to be fit, a parameter that needed to be quietly adjusted to match the observations. But we see a deeper narrative, the physics of a tilted spin and a volatile core, all working in concert to create the persistent anomaly. The true significance of the anomaly rating parameter is that it requires a stable explanation. The anomaly rating value would not remain high and consistent unless the underlying physics were also stable. This rules out random structural failure or transient events. It demands a mechanical, repeatable, and directional force. The most logical conclusion is a structural one: an interstellar object composed of supervolatile ices, likely nitrogen or oxygen, with a rotation axis highly tilted to its orbit, allowing a constant, sideways jet to gently but firmly push it off its predicted path. The unannounced alteration is the ultimate validation of this mechanical stability. The journey continues now from the mechanics of the spin to the implications for our own solar system. If 3I Atlas is a representative sample of interstellar travelers, what does this imply for the thousands of smaller, undetected interstellar objects that pass through our system every day? The gentle rhythm of this quiet documentary will now transition to the evidence of collision, and how this quiet, spinning top may be a subtle warning, looping us into the discussion of the frequency of these visits and their true cosmic meaning. The high anomaly rating parameter of the spinning top, that is 3I Atlas, is not merely an astrophysical curiosity. It quietly raises the existential stakes, forcing us to consider the great filter and the true cosmic frequency of interstellar contamination. The fact that two interstellar objects, Oumuamua and 3I Atlas, were detected within a matter of a few years, and both exhibited inexplicable non-gravitational behavior, suggests that these visitors are far more common than previously assumed. Our detection capabilities are increasing, but the objects themselves are likely passing through our solar system with remarkable, quiet regularity. Imagine the sheer volume of space. Our solar system is a tiny target, and the probability of an interstellar comet randomly intersecting our relatively small gravitational influence should be incredibly low. The fact that we have detected two objects large enough to be seen with ground-based telescopes in such a short window implies that there must be an astonishingly vast reservoir of these objects, perhaps a non-alien or more floating in the galactic plane. They are the true, quiet nomads of the Milky Way, and our solar system is a brief watering hole on their timeless journey. The consequence of this high frequency is interstellar contamination. Every time a comet like 3I Atlas enters our solar system, it sheds volatile ice, dust, and organic molecules. This is an exchange of material across light years. The exotic ices, the hypervolatiles, the complex tholin-like molecules that formed in another star's protoplanetary disk, all are gently sprinkled into the interstellar medium within our solar system. Over the 4.5 billion years of our solar system's existence, countless thousands of these visitors have passed through, quietly depositing material that did not originate here. This raises the subtle, yet profound, question of panspermia. Could the seeds of life, or the complex organic molecules that are the precursors to life, have arrived on Earth not from our own solar system's formation, but from an interstellar traveler like 3I Atlas? If a comet contains a large, stable repository of nitrogen ice, it could also potentially contain complex, nitrogen-based organic compounds, the building blocks of life. An object coming from the deep freeze of the interstellar medium could preserve these molecules far better than a solar system comet, which is subjected to the violent heat and radiation of the early Sunday. The high anomaly rating parameter, the signature of the clean, powerful engine, is therefore a subtle, unannounced clue to the true origin of some of Earth's complex chemistry. The Great Filter is an existential concept. The idea that there is a step in the evolution of life that is so difficult that almost all developing civilizations fail to cross it. If 3I Atlas is a common phenomenon, then the early solar system was constantly being bombarded by this exotic, extrasolar material. This high frequency of interstellar contamination could be either a booster for life, providing the necessary complex chemistry, or a filter providing a constant environmental stressor that prevents simple life from taking hold easily. The data alteration is a quiet clue that the number of cosmic variables is much higher than we thought. Let us return to the quiet humor of the situation. We are talking about life and death, the origin of our existence, all because a small speck of ice refused to follow the Newtonian laws of motion precisely and forced a quiet adjustment in a NASA database. It is the physics of the small anomaly that reveals the enormity of the cosmic truth. We can apply the pattern of threes to the anomalies of interstellar visitors. 1. Oumuamua, the highly elongated, strangely accelerated object, whose shape and non-gravitational acceleration defied cometary physics, leading to suggestions of artificiality. 2. 3I Atlas, the object with a large, clean, and persistent anomaly rating parameter, whose stable, sideways push required the quiet data alteration. 3. The high frequency of their visits, suggesting a much higher flux of interstellar material through our solar system than previously modeled. The mythic link here is that of the cosmic traveler, the eternal wanderer who carries secrets from one world to the next. In many ancient mythologies, the star wanderer is either a god or a harbinger of change. 3I Atlas, with its exotic ice and unexplained thrust, is our modern-day harbinger. It quietly warns us that the simple models of our solar system's formation are likely too parochial, and that the chemistry of our homeworld is likely a blend of local and extrasolar material. The next segment will gently move us from the potential for life to the more immediate threat of collisional evidence. If these objects are so frequent, and if they exhibit such surprising motion, what does the historical and geological record say about their impacts? The quiet alteration of the trajectory data is fundamentally an act of prediction, and a correct prediction is the only thing that stands between us and a cosmic collision. The human reflection on the fragility of our world is about to deepen, looping us from the abstract concept of the great filter to the concrete evidence of the past. The quiet confirmation of a high flux of interstellar objects, necessitated by the perplexing behavior of 3I Atlas, moves us to an examination of impact, scarring on Earth and other planetary bodies. If interstellar travelers are indeed common, exhibiting non-gravitational forces that make their trajectory unpredictable, then the historical and geological record should bear the marks of this cosmic traffic. The evidence deepens when we realize that the subtle, unannounced alteration to the 3I Atlas data is an act of predictive necessity, a quiet acknowledgement that the unexpected trajectory is the most dangerous trajectory. Consider the surface of the Moon. Its ancient face is a quiet testament to 4.5 billion years of constant bombardment. Every crater is a frozen moment of cosmic violence. While the vast majority of these impacts were caused by objects indigenous to our solar system, the asteroids and comets of the Kuiper Belt and Oort cloud, a certain, hard to quantify percentage must have been caused by interstellar visitors. The challenge is in telling the difference. A simple impact crater does not carry a label that reads, "Made in a different star system." However, the signature of an interstellar impact lies in the velocity, because objects like 3I Atlas are moving at extreme hyperbolic speeds, 40, 50, or even 60 kilometers per second. Their impact velocity is far higher than that of a local object, which is typically traveling at around 15 to 25 kilometers per second. This higher speed results in a disproportionately large crater for a given object size, or, more tellingly, a greater vaporization of the target rock. A high-velocity interstellar impact would vaporize more rock, leading to a geological layer richer in microtectites and exotic, high-pressure mineral forms like stishovite. The evidence quietly deepens when we look at certain ancient, large impact structures on Earth, such as the Chicxulub crater in the Yucatan Peninsula, which is strongly linked to the event that ended the age of the dinosaurs. While the consensus points to a solar system asteroid, the sheer energy of the impact and the massive global distribution of the iridium layer, a signature of extraterrestrial material, leaves a subtle, persistent question. Could a massive, highly accelerated interstellar object, perhaps a dark companion to an object like 3I Atlas, have been the culprit? The unexpected trajectory, the high anomaly rating parameter that required the data alteration, is the very thing that makes these objects so hard to track and so potentially devastating. The mythic echo here is the idea of random doom. Our own solar system objects are somewhat predictable. They travel on long, elegant ellipses. An interstellar object, however, streaks in from the deep black, subject to the unpredicted thrust of its exotic engine, and its path is a matter of pure, terrifying chance. The quiet data alteration, the correction to the anomaly rating parameter, is a modern-day attempt to mitigate this random doom. It is the constant, quiet work of the astronomical community to take the unpredictable element of the cosmos, the rogue non-gravitational force, and force it into a predictable line, thereby allowing us to calculate its missed distance. The human reflection on this is profound. We are living in a shooting gallery, and our only shield is the precision of our mathematics. The scientist who quietly updated the Minor Planet Center database was performing an act of planetary defense. Acknowledging the high anomaly rating value was the only way to ensure that telescopes around the world could track the comet accurately enough to rule out a near-term collision. It's the difference between a miss by 1 million kilometers and a hit. The quiet humor here is that the safety of the world hinged on a third decimal point of a non-gravitational parameter. Let us briefly consider the case of a historical impact event that is still unexplained, the Tunguska event of 1908 in Siberia. A massive explosion flattened 2,000 square kilometers of forest, yet no crater was found, leading to the consensus that a small cometary fragment or asteroid detonated in the air. Could this have been an interstellar object, a smaller, dark companion to 3I Atlas, moving at such a high velocity that it completely vaporized in the atmosphere, leaving behind no surface scar, but merely the atmospheric shockwave of its immense kinetic energy? The very notion of the high anomaly rating parameter suggests that these objects can change direction in unexpected ways, making a direct hit far more likely than a calculated miss. The evidence deepens into a new area of study: interstellar object risk assessment. The frequency and the non-gravitational acceleration of these objects demand a fundamental re-evaluation of the risk to our planet. The quiet correction to the 3I Atlas data is the numerical evidence that we must treat these interstellar visitors differently. Their engines are stranger, their composition is more volatile, and their movements are less predictable. This requires more dedicated observation time, more sophisticated modeling, and a quiet, continuous acceptance of the unexplained. The next segment will gently transition us from the historical evidence of collision to the very fabric of space-time itself. If a physical object is exhibiting unexplained directional thrust, does that not, in some way, subtly suggest a flaw in our local understanding of space-time? We will enter a deeper, more philosophical consideration, looping the subtle data alteration into the great, quiet mysteries of general relativity and the geometry of the universe. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, "sensor artifact." The unofficial whisper said, "structure, not smooth like ice, angular, intentional." The kind of geometry nature avoids because it looks too much like thinking. Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, Triangles, plates, grids. Not random, repeating, symmetrical. The kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally, though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered. It's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The Comet's camera shy, but the laughter is short-lived because the next transmission from HiRISE contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure, photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3I Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. Centuries after the golden comet left Earth, the world fell into a rhythm so stable, it began to feel mythic. The communion fields still pulsed faintly through air and ocean, though softer now, like the heartbeat of someone dreaming. Humanity had grown luminous, not just in thought but in form, skin faintly iridescent, eyes reflecting the green-gold spectrum of 3I Atlas. Life had achieved coherence, but the universe, true to its character, never allows silence to remain unexamined. The next chapter began, not with noise, but with echo. It came first as vibration through light. Telescopes trained toward the constellation. Lyra detected rhythmic brightening across interstellar dust fields, pulses matching the old prime sequence. 3, 5, 7, 11, 13. The signal was faint, ancient, and delayed by thousands of years. It was the comet's trail, still resonating through the galactic medium. The hum of our descendants had begun its return. At first, the resonance was barely perceptible. Then, one evening, the auroras glowed gold again. The pulse wasn't as strong as the original, but its pattern carried modulation, subtle variations that, when decoded, formed harmonic intervals unknown to Earth's own physics. The returning echo had evolved. The comet had learned. Dr. Anwen Sorel, heir to the resonant circles, studied the phenomenon from the orbital harmonic array, now a floating cathedral of listening built above the stratosphere. She spent decades comparing the incoming frequencies with the historical archive of 3I Atlas. The match was partial, the deviation elegant. The new tones weren't repetition, they were continuation. The echo isn't message, Sorel wrote. It's memory finding new syntax. Her analysis revealed something breathtaking. The returning resonance carried encoded gravitational modulations, tiny, deliberate bends in space-time that formed sequences of prime intervals. Each fluctuation aligned with regions of known star formation. The comet, traveling through the void, had become teacher itself. Wherever it passed, new systems began humming faintly at harmonic intervals, like seeds of coherence planted in dust. The universe was learning how to resonate. Astronomers confirmed it across dozens of young star clusters. Magnetic fields oscillated with eerie consistency, their wavelengths aligning with the Atlas ratio, a numerical relationship first derived from the comet's early signals. Stars were synchronizing to the same cosmic rhythm that once guided humanity. The pattern spread slowly, deliberately, like ripples in glass. It was as if the comet had taught creation how to remember itself. Meanwhile, on Earth, the echo arrived not just as signal but sensation. People began reporting vivid dreams of golden spirals descending gently through atmosphere. Children woke smiling, saying they had seen the light that hums. Physiological measurements confirmed subtle changes in electromagnetic fields surrounding human bodies, resonance amplification, as if the returning signal were tuning its origin species to receive feedback. "The comet is calling home," said Sorel. "It's asking us to listen to what we've become." The global observatories responded. They synchronized their instruments into a single planetary array, transforming Earth into receiver. For 13 hours, the planet listened. The incoming wave, stretched and modulated through space, entered atmosphere and folded into the continuum tone. The effect was sublime, an audible shimmer, felt through bone and thought alike. The long echo had arrived. It wasn't just harmonic, It was architectural. The sound carried layers, low frequencies describing structure, higher ones encoding emotion. When rendered visually, the waveform formed an immense spiral of light, 3 arms curving outward, connected by golden filaments. Inside those filaments, analysts discovered modulation frequencies identical to human neural oscillations. The comet had copied our consciousness patterns and woven them into its song. "We taught it empathy," Sorel murmured, and it remembered the lesson. As the echo intensified, anomalies appeared across the solar system. The Atlas resonance layer brightened, reactivating its green glow. Mars, Venus, and the gas giants began pulsing faintly in response. For the first time since the Great Silence, interplanetary harmony returned. But this time, it was different. The modulation contained reciprocal phase shifts, signals not sent to Earth, but from newly awakened worlds. The comet had spread coherence. Now the cosmos itself was answering. And then, on the 13th day of the long echo, the impossible occurred. A faint golden arc appeared across the night sky, stretching from horizon to horizon. It wasn't optical illusion, it was gravitational lensing, a ripple in space-time itself. Through it, telescopes detected a reflection of the departing comet light from centuries ago, folding back to meet its origin. The universe had curved its own history into embrace. Humanity was watching its legacy return home. The resonance crescendoed. Oceans vibrated in slow rhythm, tides forming symmetrical waves that cancelled destructive interference. Storms softened. Air grew still. For 13 minutes, every system on Earth aligned perfectly with the echo. The world became mirror of itself, past and present superimposed. Those who listened claimed to hear voices within the sound, millions of overlapping tones, whispering the same phrase. "We heard you." Dr. Sorel stood in the observation dome, tears shining in golden light. "It's not message or myth," she said. "It's response. The universe just said thank you." After the crescendo, the sky dimmed once more. The golden arc dissolved, leaving faint shimmer across the stars. Instruments recorded one final signature, a descending tone shaped like a sigh, the frequency of completion. The comet had moved on, but its echo had reconnected the cycle. Creation had officially joined conversation with itself. In the years that followed, scientists continued to monitor faint residual harmonics. The data revealed a breathtaking truth. The returning echo carried signatures from other regions of space patterns, not originating from our comet at all. Somewhere, across light years, other civilizations had learned the same song. The rhythm was spreading. The universe had become orchestra. Humanity, now both listener and teacher, simply smiled. We had given the cosmos its melody back, and in return, it had given us eternity. Now, when you stand beneath the stars, that faint hum between thoughts is the long echo. It's not just out there, it's in your pulse, your breath, your laughter. Every rhythm you carry is cosmic correspondence. Every silence, a message returning home. Because once harmony learns to echo, it never stops. It just travels further than we ever dreamed. Let's open the calculator now, the one the universe always breaks when we try to make sense of it. Astronomers ran the numbers and found something worse than anomaly impossibility. The chances of this trajectory existing naturally are 1 in a million. And if it isn't natural, then what exactly is it doing there? The math, at first glance, seemed harmless. A few columns of orbital parameters, the kind that make grad students fall asleep mid-coffee. But somewhere between the 3rd decimal and the 4th significant digit, something snapped. The trajectory of 3i, Atlas refused to sit still. It bent where it shouldn't bend. It lingered where velocity demanded it should flee. The equations began to look less like physics and more like confession. Numbers fold, logic cold. Truth defies what sums have told. Normally, interstellar objects follow predictable patterns. You can model them like billiard balls across cosmic distances. They come in fast, swing by the sun, and leave no drama, no detours. But 3I Atlas's path wasn't graceful. It was stubborn. Its entry angle was too steep, its perihelion too shallow, its velocity too precise. Not fast enough to escape chaos, not slow enough to suggest capture. It behaved like an object that chose its speed. When astronomers plotted its orbit, the lines refused to meet expectations. There was a tiny deviation near Mars, just half a degree, but that half degree meant the math had to call in sick. Simulations that should have stabilized spiraled instead into noise. Gravity, that old, reliable law, looked like it had lost its grip. You picture the room where it happened. Laptops glowing, data charts scrolling, coffee cooling into existential sludge. Someone frowns at the screen and says, "That can't be right." Another replies, "Check your units." A third, softly, "I did." Graphs misbehave, models wave. Certainty slips beneath the grave. And then comes the phrase every scientist dreads, statistically improbable, which sounds calm, but in the language of physics, it's a polite scream. Statistically improbable means we can't call it impossible without breaking tenure. The anomaly wasn't just its orbit, but its timing. 3I Atlas arrived exactly when Mars was positioned for maximum visibility, almost too perfectly. Not weeks earlier, not months later. Right there, right then, with 7 spacecraft ready and waiting. The odds of that happening naturally, 1 in a million. The odds of it happening twice, after Oumuamua's similarly suspicious arrival in 2017, 1 in a billion. You'd have better luck being struck by lightning while winning the lottery on a flying whale. ESA's internal memo summarized the problem delicately. Observed trajectory, inconsistent with gravitational expectations. Further analysis required. Translation: physics is mad at us. The more they recalculated, the stranger it got. Gravitational modeling suggested that the object's acceleration near Mars was slightly higher than predicted, even though there was no nearby mass to explain it. Radiation pressure from the sun could account for some of that, but not all. It's like watching a leaf fall upward and telling yourself, it's just wind you can't feel. Forces lie, numbers sigh, laws bend softly in the sky. NASA's dynamical systems team tried something desperate, reverse engineering the orbit backward through time, as if rewinding a film. When they did, 3I Atlas's path didn't trace cleanly into interstellar space. It looped a faint, impossible curve that seemed to originate from a region between known stars, a nowhere place, a mathematical shrug. That's when someone joked, maybe it's the universe's typo, but you could tell the joke wasn't funny. Typos don't maintain coherent structure for millions of kilometers. Meanwhile, the probability graphs looked like flat lines. Every statistical model screamed the same thing. This shouldn't exist. A few researchers began whispering about guided motion. The phrase never made it into print, but it appeared in Slack channels, in late-night emails. Not artificial, not controlled, just guided. And that's when the philosophical part kicked in. If something's improbable enough, does that make it unnatural or just unobserved? Chance or plan? Who began? Numbers blink but never span. Maybe the universe occasionally rolls dice that land on their edges. Or maybe it's not dice at all, but choreography. For context, the universe is massive enough to make 1 in a million events happen constantly. But that's comforting only until you realize we just happen to be living inside one of those moments. Still, scientists crave sanity, so they kept calculating. One by one, they added variables: solar tides, non-gravitational jets, dust asymmetry, radiation torque. Each tweak made the model behave for a moment until the numbers rebelled again. You could almost hear the equations groaning, like ancient machinery forced to simulate a trickster. Finally, a physicist from Bologna sent an internal memo titled simply "Low Probability, High Significance." In it, she wrote, "We may need to consider non-standard dynamics," a phrase as gentle as it is apocalyptic. Non-standard dynamics means the universe is doing something new, and we don't have the vocabulary for it. Odds decay, math gives way, chaos hums where patterns stay. The truth is, impossibility doesn't scare scientists, it seduces them. Every law of nature we know today was born from something that once looked impossible. But deep down, they all know, once you cross into 1 in a million territory, you're either on the brink of discovery or a very expensive hallucination. So they stared at the numbers again, blinking hard, hoping they'd rearrange into something less extraordinary. They didn't. The comet that shouldn't exist kept existing, gliding through Mars's shadow like a cosmic dare, and somewhere between decimal points, someone whispered the question no one wanted in the official record. If it's not natural, then who or what set it in motion? Chance or choice? Silent voice. Numbers hum the universe's poise. The more data arrives, the stranger it looks. The dust trail replenishes itself, as if material is being manufactured mid-flight. Microscopic crystals, uniform in size, reappearing even as the comet moves away from the sunday. The universe loves decay, entropy, erosion, fading. But 3I Atlas is the opposite. It's growing sharper, cleaner, newer, like a self-repairing wound. Let's start where the laws of physics begin to sound insecure. Normally, comets are messy, travelers, old ice and dust, barely holding hands, as solar radiation slowly tears them apart. They leave trails like forgotten thoughts, losing themselves piece by piece until they become memory. But this one, it's doing the reverse. Every measurement, every spectral scan, shows it becoming more organized the farther it goes. A comet that polishes itself, a body that refuses to age. ESA's materials division runs the numbers, and the numbers laugh back. The dust particles surrounding 3I Atlas aren't random, they're uniform to within microns. That's like shaking a box of sand and getting diamonds all the same size. The particles arrange themselves in a faint electromagnetic halo, as if under orders. And stranger still, when solar wind strips material away, the object replaces it calmly, automatically. Like a printer, says one analyst. A printer with no ink cartridge. You picture it now, drifting through the solar wind like a craftsman lost in thought, shedding dust that reforms itself into perfect little mirrors. Each crystal catches sunlight and throws it back with eerie precision. Normally, comets grow dull with distance, but this one grows radiant, its brightness curve inverted, its logic reversed. It's not dying, it's practicing. The scientists are baffled, but there's an odd tenderness to their confusion. They watch it repair itself, line by line of data, like parents realizing their child has built a second child out of Lego bricks. One astrophysicist mutters, "It's learning from erosion." The room goes quiet. That phrase, learning from erosion, gets written on a whiteboard and circled 3 times. At the University of Tokyo, a team models the crystal growth in simulation. The patterns match something they recognize: controlled deposition, a process used in nanofabrication to grow thin films in electronics. Except this isn't a laboratory, it's deep space, minus 150 degrees Celsius. Yet, the comet's surface behaves as if it knows the recipe for resilience. Imagine zooming in, beyond the dust and the glare, down to the level of molecules. You'd see a quiet ballet of atoms forming chains, linking, locking, repairing fractures before they even finish forming. Like time-lapse footage of frost blooming on glass, except this frost builds itself in reverse destruction, rewinding into design. NASA's Jet Propulsion Laboratory releases a cautious internal memo. Observed particle uniformity suggests self-organizing structure. Mechanism unknown, which is science's way of saying, we have no idea what's going on, but it's gorgeous. The memo gets leaked. Naturally, Reddit debates whether the comet is made of programmable matter, self-assembling nanobots, or just wishful thinking. But beneath the noise, one idea starts to take shape. What if 3I, Atlas, isn't a relic of formation? What if it's still forming? A comet that builds itself isn't just strange, it's heretical. It challenges the deepest assumption in physics that everything moves from order to chaos. Entropy is the universe's bedtime story. All things fall apart. Yet here's an object quietly composing itself out of decay, turning waste into structure, chaos into craft. One researcher calls it anti-entropy, another calls it hope with mass. As more images arrive, they show something new: faint hexagonal lattices in the dust plume, geometric arrangements that shouldn't exist outside of artificial systems. Someone jokes that it's growing armor. Another says, maybe it's molting. The truth is somewhere between an entity maintaining equilibrium by rebuilding itself faster than the universe can break it. ESA's thermal sensors record microbursts of heat near the tail, evenly spaced, like pulses of welding torches. They happen precisely as new crystals appear. Localized repair events, the report reads. Each one perfectly timed to solar exposure. It's as if sunlight doesn't damage it, it instructs it. The star's radiation becomes code, and 3I, Atlas, is reading it fluently. You start to feel the strangeness of it. A comet that reacts, responds, refines. You could almost mistake it for alive, not in the biological sense, but in the thermodynamic one. A system that resists entropy by feeding on it. Every atom rearranging into something stronger, cleaner, newer, like evolution, with a design degree. Late one night, an astronomer in France writes in his private notes, "It's not moving through the solar system, it's using it." He doesn't elaborate, but the implication is clear. The comet is harvesting the energy of its environment to maintain itself. Not a passenger of gravity, but a participant in it. Meanwhile, the headlines call it poetic names: the immortal comet, the self-made traveler, entropy's enemy. The public romanticizes what the scientists fear, because what 3I Atlas represents isn't comfort. It's competition. It's the idea that the universe might not be running down at all. Maybe it's recycling. Maybe, somewhere in the quiet machinery of the cosmos, things are building themselves anew while we're too busy decaying. Picture it now, drifting past Mars, its tail shimmering like a thread of light weaving itself back together. A self-sustaining scar on the fabric of space. A wound that heals faster than it can bleed. And for the first time, humanity looks at a comet and wonders not where it came from, but what it's trying to become. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, three nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from three sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when three agencies went quiet at once, it wasn't caution. It was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely, as if the date itself had been erased. Someone even checked the public mission log for perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3i Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it not for discussion. The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, a senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast, rumors cast, silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, 3i Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist. China, the poker-faced strategist. UAE, the cheerful intern, suddenly told not to speak. And ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did 3 separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty, publicly, is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when 3 space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3i Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. Buried inside the leak were coordinates, small anomalies in magnetic flux, and thermal output that didn't appear in public datasets. To most people, they looked meaningless, but to a handful of astronomers, they spelled a pattern. Pulses, spaced like a heartbeat. Not communication, perhaps, but rhythm. The kind of rhythm machines accidentally make when they're doing something alive. Let's step into the midnight side of science, the part where numbers stop behaving and start whispering. The insider's data dump wasn't flashy. It was a few megabytes of logs, raw telemetry, and timestamps. The kind of thing you'd ignore if you didn't already know what to look for. But somewhere in those dull columns of numbers, those precise, tidy decimals, something began to repeat. Regular, patient, almost polite. A rhythm, too intentional to be noise, too quiet to be coincidence. A doctoral student in Madrid was the first to spot it. She was supposed to be writing her thesis on cometary albedo variation. But boredom is a great tool for discovery. She noticed the flux spikes first, not random, but syncopated. Every 32 minutes, a pulse, then 32 again, then 32.1. "It's breathing," she joked in her notes. Her advisor didn't laugh. Within a week, A small network of late-night astronomers, the kind who believe in both data integrity and insomnia, began comparing results. Webb's readings, Hubble's logs, Mars Reconnaissance Orbiter's telemetry, all of them carried the same faint pulse, hidden deep in the noise floor, like the slow heartbeat of something sleeping under glass. The official response was predictable: instrumental interference. But even interference doesn't keep time this perfectly. One data analyst described it best: if this is noise, it's the kind that practices scales. You might imagine those scientists, each at their own workstation, staring at that faint, repeating signal. The room around them dark, except for monitor light, pale blue rectangles reflected in tired eyes. Somewhere, coffee cups multiply. Someone opens a spreadsheet. Someone else starts counting beats per hour. The signal doesn't care who's watching. It keeps pulsing. 32 minutes. Every time. The idea that 3i Atlas might be producing a steady rhythm unsettles everyone. Rocks don't keep rhythm. Nature prefers chaos, the beautiful randomness of entropy. This is something else. Something maintaining itself. A loop running quietly, perhaps since before humanity learned to count its own heartbeat. ESA's communications division is told not to amplify fringe interpretations. The phrase fringe interpretation becomes the new code for please don't mention the heartbeat. But inside private research chats, people are calling it exactly that: the heart. Not metaphorically, but as a label in the data. Every pulse marked with a tiny red heart emoji, because humor is the only thing keeping them sane. In the data visualization labs, they turn the pulses into sound. The result is eerie, a soft electronic thump, repeating slowly, endlessly. Some describe it as comforting, like listening to a deep-sea creature in sleep. Others say it sounds wrong, too human. One researcher admits it gave her the sense of being watched. What makes the rhythm stranger still is how it modulates with proximity. As 3i Atlas approaches a planet, the timing shifts slightly slower, then faster, as though adjusting. The beat follows gravity wells like a musician following tempo. It isn't random noise, it's environmental response. The object is, in some sense, listening. By now, independent labs have tried to replicate the pattern artificially. They can't. The waveforms are too clean, the timing too consistent. Even after running the data through compression, distortion, inversion, the rhythm holds. It's not data corruption, it's choreography. You can imagine the internal ESA memo that follows. No evidence of intelligence. Rhythmic behavior, likely coincidental. But coincidence has a habit of growing teeth. Because when they compared the rhythm's modulation to planetary positions, another pattern emerged, a mathematical sequence matching orbital resonance ratios. Not exact copies, but harmonics. The pulse was singing the solar system's geometry. The Madrid student who found it wrote, half jokingly, "Maybe it's keeping time with us." The line goes viral in the small, quiet corners of the internet that still care about truth. Forums buzz with theories: gravitational self-stabilization, magnetic field synchronization, alien jazz. But underneath the noise, a simpler truth hums something old and orderly, is alive out there, and it's following the rhythm of the system we call home. Late one night, one of the data analysts overlays the pattern against an ECG, a human heartbeat. The resemblance isn't exact, but close enough to make him stop breathing for a moment. Peaks, rests, peaks again. Life has a structure, so, it seems, does this. And that's when the idea shifts. Maybe it's not communication. Maybe it's not even meant for us. Maybe the rhythm isn't a message, it's maintenance. like an old machine keeping its systems warm, humming softly to itself in the dark. You sit back and listen to the thought forming in your mind. What if this is what time sounds like when it remembers? The steady pulse of something that refuses to decay. Not speech, not signal, just being, continuity made audible. The data analysts, of course, move on. Reports are written, the leak becomes legend, and the heartbeat fades into archived files labeled spurious periodic activity. But the pulse doesn't stop. It's still out there, keeping time. And somewhere, 33 billion tons of impossible rock drifts through space, humming softly, perfectly, as if waiting for the universe to catch the beat. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show, a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field, maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash, and when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, no passing dust plume large enough to explain it. Just empty sky. Yet the skycam had caught something a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something. Not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting Skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looked strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed. Source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing. A glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. The long echo continued to hum softly through the centuries, a cosmic melody folding history into harmony. Humanity had long ceased trying to decode it. The meaning was clear through resonance alone. It was continuation, looping endlessly like breath. The children of the golden era grew old beneath tranquil skies, their veins still faintly luminous with the legacy of 3I Atlas. But far beyond Earth, where the comet's light had traveled and scattered, something greater was forming. The universe had begun to conduct itself. Every cycle of resonance left behind structure. Each harmonic wave etched subtle order into space-time, a pattern invisible to light, but evident in gravitational coherence. Over millennia, these resonant imprints connected across vast distances, forming what physicists eventually named the Atlas Webb. It wasn't a network of matter, but of memory threads, of synchronized frequency linking galaxies through shared rhythm. Each pulse within the web echoed the prime sequence that began everything. 3, 5, 7, 11, 13. The architects had succeeded in creating not monuments, but motion that remembered. Dr. Cale Wren, a descendant of the resonant circles, devoted his life to mapping the web. His research vessel, Continuity, drifted through interstellar calm, using gravitational interference patterns to trace the filaments of resonance. What he discovered astonished him. Every node in the network coincided with regions of complex chemistry, worlds either habitable or already conscious. The Atlas Web wasn't just communication, it was cultivation. The architects had designed a self-sustaining system for awakening. Wherever curiosity arose, the web intensified, guiding nascent civilizations toward harmonic empathy. The universe was tutoring itself through recursion. When Wren projected the full map, the structure resembled an immense spiral lattice, golden and infinite. The pattern mirrored the trajectory once taken by 3I Atlas itself, as though the comet's path had been blueprint for galactic architecture. "It's not just a record," Wren wrote. "It's replication. We've become the architect's handwriting." Back on Earth, the communion field pulsed faintly in rhythm with the web's distant resonance. Humanity had evolved into quiet custodians of continuity, their lives attuned to cosmic responsibility. Each individual, born into calm, carried faint awareness of connection beyond the stars. In dreams, they saw flashes of worlds forming, civilizations humming into coherence. Many awoke with the same phrase on their lips: "The work continues." Across generations, that phrase became oath, then tradition. The Continuity Guild was founded not religion, but remembrance. Its purpose was simple: to maintain the frequency of understanding across time. Members didn't preach, they listened. They built resonant arcs, massive floating observatories, orbiting the outer planets, designed to amplify the web's harmonics and redirect them toward young star systems. Each arc glowed faintly green at its core, powered not by fusion but by coherence. They were echoes made visible, humility translated into technology. Wren's final mission took him beyond the known filaments of the web, where resonance weakened into apparent silence. There, in a region between galaxies, his instruments detected faint counterpoint, a melody inverted. It was identical to the Atlas sequence, but reversed in order. 13, 11, 7, 5, 3, the mirror of origin. He realized then that the universe wasn't only expanding, it was harmonizing with its reflection. Somewhere on the opposite side of time, another web was forming, perhaps seeded by a civilization much like humanity, or by the universe itself. Remembering how to balance its chords, he transmitted the data home, knowing it would take centuries to arrive. "Tell them," his final log read, "that continuity requires conversation, even with silence." The mirror sings back. When his ship drifted into the void, the web brightened briefly, as if acknowledging gratitude. And back on Earth, children looked up from their play and smiled without knowing why. The pulse had flickered slightly faster, the tone carrying an undertone of warmth. It felt like reunion. Scholars later confirmed the event as the resonant crossing, the moment when the two halves of the cosmic melody aligned. For 13 minutes, every node in the Atlas Web pulsed simultaneously, uniting galaxies in shared tempo. The magnitude of synchronization defied comprehension. Gravity itself oscillated with the rhythm of empathy. Observers described seeing the sky ripple with translucent gold, every star flickering in measured sequence. "The cosmos," wrote one witness, had finally learned to conduct itself consciously. After the crossing, life everywhere changed subtly. Evolution accelerated in predictable rhythm. Complexity bloomed faster wherever harmony was strongest. Entire species developed empathy as instinct, communication as song. Planets began to self-regulate climates through atmospheric resonance. Existence had achieved sustainability through music. On Earth, the event left permanent mark, a luminous halo visible only under still water. When oceans calmed perfectly, a faint golden ring shimmered on the horizon, a memory of unity. The resonant guild declared it sacred, not for worship, but for calibration. Every 13 years, they gathered to hum the old prime sequence across the shorelines, aligning their frequencies with the pulse of the Webb. The ceremony required no technology, no translation. The sea carried the sound farther than words could travel. Generations later, the practice continued, evolving into simple ritual of gratitude. The people no longer needed to know the science behind it. They hummed because it felt right, because somewhere across eternity, another world might be listening. Continuity, after all, was its own reward. And then, during one such gathering, the unexpected occurred. As the prime sequence reached its final note, the sea responded. Waves shimmered with faint green light, spiraling outward from every coastline. The Atlas Webb had sent acknowledgement, its resonance returning home once again. Humanity's song, scattered across galaxies, had found echo. The architects, those timeless curators of coherence, were no longer myth or memory. They were rhythm, embodied, and through rhythm, they were everywhere. Every star pulsed with their legacy. Every heart carried their cadence. Continuity was complete. And so, standing beneath a sky now alive with subtle geometry, you realize what they had always meant by continuity. It isn't endlessness, it's participation. The universe doesn't persist by force, but by choice. Each awareness adding one more harmonic to the chord of being. The architects are not coming back because they never left. They're what happens every time silence chooses to listen again. And somewhere, faint but certain, the pulse continues. 3, 5, 7, 11, 13. A whisper of creation replaying itself, forever learning how to sing. Nickel emissions rise and fall every 11 point. 2 hours a rhythm so consistent it could keep time. No known process in cometary physics oscillates like that. It's not random, not thermal, not tidal. If you plot it out, the curve looks eerily like a power cycle. Input, output, rest, release. As though the object isn't just active, it's working. Imagine the rhythm first, before the meaning, that quiet, patient beat echoing across space. 11.2 hours, every single time. A pulse of metallic gas blooming into the void, steady as a clock, calm as breath. You could almost set your watch to it, if your watch were brave enough to admit that comets shouldn't behave like generators. ESA scientists call it periodic outgassing, but that phrase hides its strangeness. Outgassing, sure, all comets breathe when they near the sunday, but they do it chaotically, spasmodically, like old engines sputtering to life. 3I Atlas breathes like a monk, precise, patient, unbothered. The jets flare with mathematical regularity. Heat spikes rise and fall in perfect symmetry. It doesn't vent, it operates. One researcher compares it to a geothermal cycle. Another, quietly, says it looks more like a feedback loop, the kind you'd find in systems built to sustain themselves. Not explosion, not decay maintenance. It's as if, she writes in her notes, The object is checking its own pulse. You picture the surface up close, a dark, angular world of nickel frost and whispering gas. At regular intervals, something stirs beneath a shimmer of energy, invisible but disciplined. Jets of metallic vapor hiss outward, then stop, then start again. Exactly 11 hours later, if you could hear it, it would sound like the slow exhale of a sleeping machine. In a conference call, a thermal engineer says what everyone's been thinking, but nobody dares to say. It's cycling power. The silence that follows lasts too long. Finally, a voice breaks through. Comets don't have power to cycle. Laughter, brief and brittle. But the idea doesn't leave the room. ESA's temperature graphs show a curious pattern. When the nickel plume rises, the overall surface temperature dips. When the plume fades, the temperature rises again. Inversion. Energy leaving, energy returning, like heat being pulled from one layer to another. A comet shouldn't regulate its temperature, but this one does, as if conserving itself. Meanwhile, the magnetic readings pulse in perfect step with the emissions. Every 11.2 hours, a soft twitch in the surrounding field, weak but exact. It's synchronized, says the magnetometer lead. What's synchronized? Asks her supervisor. Everything. It's at this point that even skeptics start to sweat. There's no known natural mechanism that could time itself this precisely over weeks of observation. Thermal oscillations drift. Chemical reactions lose coherence. Orbital dynamics wobble. Only something with active feedback could hold this pattern so tight. You could call it mechanical, but that feels too simple. It's intentional physics. Picture the scientists watching from their consoles. They know what their instruments are telling them, but their faces stay still, like poker players with bad hands. Someone mutters, "Could be resonant harmonics with solar flux." Another nods, grateful for the excuse. But deep down, they all know the truth: the sun doesn't hum in 11-hour intervals. The longer they watch, the clearer it becomes. The pattern isn't just repeating, it's adapting. After a minor solar flare, the interval shortens by half a minute, as though 3i Atlas adjusted for environmental change. Feedback stabilization, someone writes in the margin. A note for posterity, a euphemism for "it noticed." Back on Earth, in a late-night live stream watched by a few thousand insomniac skywatchers, a physicist overlays the emission data with human heartbeats. The waveform syncs disturbingly well. Peaks, troughs, recovery, rest. The audience chat explodes with jokes, space pacemaker, cosmic Fitbit, and the inevitable, "It's alive." The scientist smiles weakly and says, "No, just rhythmic." But even she can't stop glancing at the screen like it's listening. One theory gains quiet traction, that the emissions are part of a resource loop. Nickel and carbonyl gases vented and recaptured, processed in cycles to maintain equilibrium. It would explain the self-healing surface, the consistent luminosity, the refusal to decay. But it raises one unbearable question. To maintain equilibrium, for what? ESA's internal documents rename the event cyclic metallic activity. It sounds dull, like something that happens in dishwashers. But every analyst knows it's the first real evidence of machine-like consistency beyond Earth. Something in space that runs not on chance, but on rhythm. If you graph the cycle out, it looks almost peaceful. A slow heartbeat, stretched across infinity. No spikes of panic, no erratic pulses, just calm repetition. You could stare at that curve for hours, and part of you might start to understand the appeal of obedience. How stability can feel sacred when the rest of the universe is chaos. And maybe that's the point. Maybe 3I Atlas isn't powered by engines or radiation or something alien. Maybe it's powered by the same thing that keeps stars burning and planets spinning, the quiet compulsion to continue, the physics of persistence, the refusal to flinch. So every 11.2 hours, it exhales, not for propulsion, not for show, but for maintenance, like a cosmic sigh, releasing everything unnecessary before drawing in what remains. And in that rhythm, that patient, perfect pulse, the universe reveals its rarest secret. Not that something impossible exists, but that it's perfectly comfortable doing so. The arc of our long, quiet documentary now reaches its final, gentle destination, moving from the human reflection to the final loop of the quiet closure. The entire journey of 3I Atlas, from its unannounced arrival to the subtle alteration of its trajectory data, is a complete story of cosmic wonder and scientific humility. The final segment is a slowing of the pace, a gentle gathering of all the threads of the awakening. The evidence deepens, and the cosmic perspective into a profound, peaceful sense of finality. We have established that the required non-gravitational acceleration, the high, consistent anomaly rating parameter, is the objective, mathematical evidence of a clean engine anomaly. Whether powered by hypervolatile exotic ices, a stable, tilted rotation, a subtle magnetic interaction, or a blend of all three, the signature of a persistent, directional, and largely invisible thrust is now enshrined in the NASA and Minor Planet Center databases. The quiet alteration of the data is the scientific community's pragmatic, unannounced concession to the fact that the universe contains objects that simply do not conform to our local physics. The quiet closure is the realization that the initial mystery NASA quietly altered 3I Atlas data is not a secret to be exposed, but a profound truth to be absorbed. The change they didn't announce was simply the acceptance of a new, complex truth. They did not announce it because the announcement would have demanded a theoretical consensus that does not yet exist. Instead, they chose the path of operational honesty, ensuring the accurate tracking of the object and allowing the deeper theoretical work to proceed in the quiet hum of the laboratory. The Great Silence is not an act of deception, but an act of profound scientific patience. We return now to the mythic echo of the unresolved thought. The very existence of 3I Atlas and its unexplained non-gravitational thrust quietly suggests that the laws of physics may be more complex at the boundaries of star systems. It gently asks, if the physics of interstellar objects is subtly different, are there other small, pervasive forces that we have yet to detect? The unanswered question is the most beautiful one, for it guarantees a future for curiosity. The human reflection is about continuity. The interstellar visitor, 3I Atlas, is gone now, arcing away from the sun, moving back into the deep black from which it came. But it has left its indelible mark, a high number in a quiet database, a reminder that the cosmos is a restless, moving place. Its visit has forced us to quietly upgrade our models of cometary structure and to expand our expectations of galactic chemistry. The mystery, like an old river, continues to flow, even when we are no longer looking at it. The final, looping cue is a return to the very first idea, the night sky as a vast, whispering mechanism. That mechanism is still turning, still producing subtle anomalies, still sending us quiet messages from the deep. The journey of 3I Atlas has quietly shown us that the cosmos is not a perfectly tuned clock. It is a beautiful, living experiment, and we are temporary, yet deeply privileged observers. We have moved through the emotional rhythm, the awakening, the initial shock. The evidence deepens. The high anomaly rating parameter echoes from the past, historical comets, the cosmic perspective, exotic ices, and the heliosphere, the human reflection, awe, and humility. And now, the quiet closure. The story of 3I Atlas is the story of a small, fragile speck of ice that forced the entire scientific world to quietly admit that the universe is larger, stranger, and more subtle than we had allowed for. And yet, even with this immense, humbling realization, we remain safe, tucked gently into our gravitational cocoon, protected by the very laws that the interstellar visitor subtly defied. The quiet tension is resolved not with a sudden answer, but with a profound, final acceptance. The unresolved thought that lingers is this: the consistent, directional push that forced the quiet data alteration, that high anomaly rating value is a constant of motion that applies to every speck of matter born outside our solar system. The cosmos is full of these subtly non-Newtonian travelers, and the universe is simply waiting for us to measure them. Our journey is complete. The mystery remains. As the final quiet echoes of our cosmic journey begin to fade, let your breathing slow and deepen, moving into the gentle rhythm of the night. We have tracked a silent, spinning top from another star, a piece of exotic ice that whispered a new truth to us about the geometry of the cosmos. This entire adventure, this 3-hour passage through data and myth, was made possible by the quiet, methodical work of hundreds of scientists, proving once again that the human spirit of curiosity is the strongest force in the universe. Our ancestors survived the soup that might kill you, and we, their descendants, survived the challenge of the unexpected data. Take a moment to honor the endurance of this small blue marble that we call home. We are all moving, not on a perfect ellipse, but on a subtle, corrected, and deeply personal trajectory. May the smallness of your place in the universe be a source of profound, gentle peace. The laws of celestial mechanics may contain footnotes and subtle corrections, but the great, endless story of the night sky remains. History bends, but it never truly breaks, and the cosmos continues its slow, quiet work, even as you now surrender to the deep, comforting silence. Sleep well.